Chemistry practical number 1, making salts. You will need to prepare a pure dry sample of a soluble salt from an insoluble oxide or a carbonate, using a Bunsen burner to heat dilute acid and a water bath or an electric heater to evaporate the solution. So I've already set up my Bunsen burner. First thing we're going to do, we're going to measure 100 millilitres of sulfuric acid. Now, because this is not a quantitative experiment, we don't have to be very, very precise. So I'm just going to use the graduations on my beaker. Now, if we were going to be doing any measurements afterwards, I would need to be using a measuring cylinder. But because we're not, the graduations will be fine. I'm going to fill that up to roughly 100 millilitres, give or take, just there. Now, I'm going to heat that on my Bunsen. Currently on the safety flame, I'm going to put my gauze on first. Going to put my solution on there. Now, you don't want it to be on a full roaring flame. I'm going to open the air hole about halfway. And then I'm going to wait for that to look like it's just starting to boil. Now, we are heating this to increase the solubility or increase the amount of solute that can be dissolved in this solution. When we add the copper oxide, the reaction is going to produce a soluble copper sulfate solute. So warmer solutions can have more dissolved in them. The same way that you can dissolve more sugar in a hot cup of tea than a cold one, this means that we can have more solute dissolved in the solution. It's just a real-world application of a principle that we're using here. So here we can see some bubbles are just starting to be produced at the bottom. That means it's nearly at the boiling point. So what I'm going to do, we don't want that to boil because it's acid. I'm going to turn my Bunsen burner off. This is as hot as I can get it before it starts getting dangerous. Once you have turned the Bunsen burner off, you're going to add small amounts of copper oxide. Now, if you add this too quickly to a warm solution, the reaction's going to happen very, very quickly and you will get it fizzing over the edge and it's quite dangerous. So, not even a full spatula, I would do just tiny amounts at a time to control the rate of the reaction. Again, we're not doing exact measurements because we're not going to be weighing them afterwards. This is just a method that you need to know. Stir that to make sure it has fully reacted. Now, again, it looks like the solution is black. This is purely because the copper oxide is insoluble, so we can still see the colour. Inside this solution will be some dissolved copper sulfate. And that's what we're going to make our crystals from. Once your solution has cooled down enough that you can touch it, make sure you check with your teacher for when this is going to be possible. We're going to filter the solution to remove any insoluble copper oxide still in the container. Here I've prepared some filter paper in a funnel and I have a conical flask that I'm going to use to contain the solution. So we've already mixed this. We're going to pour this through nice and slowly and immediately we can see a fine trickle of solution containing copper sulfate. Now, here the solution coming through is still quite dark, so we may have to filter this again as some of the copper oxide is getting through into our solution. That's not what we want. Your solution should be a deep blue colour like this one here. This is a solution of copper sulfate dissolved in water. So what I'll do is I'll filter the rest of this through. Okay, and we will filter it again and hopefully get a colour like this. So I've filtered this 2 more times just to be sure. I still have the insoluble copper oxide that has been removed. This is a pure solution of copper sulfate dissolved in water. Now we're going to crystallise this in the second part of the video and show you how to do so.
So we don't tend to do this in class, just like we don't tend to heat the sulfuric acid in class. So in the first part of the video, we tend to use cold sulfuric acid. It's a similar sort of process, but obviously as you heat it, it is much faster. This time, again, we don't tend to do this. We tend to use a Petri dish, which I'm going to show you later, one of my students. But I'm just showing you what AQAE have set out for us to do. The first thing you need is an evaporating basin, which looks like this. You'll need a beaker filled with water, and you will pour your copper sulfate solution. The soluble copper sulfate has been dissolved in the water or dissolved in it. Okay, you'll pour it in. Now I'm not going to pour it all in because clearly I don't want it spilling over and I don't want it spitting out at me. And you put this on the water bath. This is so it's gently heating it. Clearly I could heat the evaporating basin straight, but it wouldn't be gentle enough and it would really start to spit out and it wouldn't work as well. Also worth noting, the faster you heat something, the smaller the crystals are going to be because they don't have time to kind of form around their nucleation sites. So I'm just gently heating this evaporating basin and you should start to see it slowly get less and less as the water is evaporated off. Okay, that should therefore leave me with just the copper sulfate there. We could keep doing this consistently until I've got rid of all of this. Now while it's heating, I'll show you some of my students. At school, we tend to place them in a Petri dish and let them naturally form on their own. And you can see with this student, there's a giant crystal. That's because it's taken so long to form, okay? Whereas these would probably slightly smaller crystals because I'm heating them up. Now I also want to show you another one. Again, this has moved slightly, but you've got multiple crystals here. And then finally, I want to show you this one. We've got a really large copper sulfate crystal, but you can also notice some of the insoluble copper oxide. Clearly, they didn't filter it enough. So you've got to keep refiltering it until you've got all of the black copper oxide, the insoluble copper oxide removed. Otherwise, you'll get black parts next to the crystal. Now, I'm going to keep heating this until I start to notice some kind of small nucleation sites, some small grains of crystals forming. You're then supposed to leave this in a cool place for at least 24 hours. Obviously, it's until the water evaporates, really, leaving those crystals behind. Once the crystals start to form here, once those small, tiny grains that you can only just visible start to form, you're forming a nucleation site. And obviously, the longer you heat it, the more nucleation sites you will kind of form. However, you want big crystals. So we would take this off the heat, away from this water bath, which you can clearly see is working very nicely there. We would take it off the heat and we would put it in a dry place for around 24 hours to make those crystals form, because the water will be evaporating away from those crystals. Now, I don't know if you can see it that well, but there are a few starting to form, and you can clearly see some steam coming from the water bath, and I can slightly see some steam coming from the actual evaporating basin, which gives me a lot of hope that this experiment is working exactly how it should. We've noticed from some of the actual AQA mark schemes and the actual AQA questions that they also like you to mention this. If the crystals aren't dry, it's worth getting a paper towel and just gently dabbing them, okay, to soak up some of the leftover water. And some mark scheme even mention a little bit about rinsing some of the excess residue off, but we're talking minor amounts of water. But it's always worth mentioning those in those sorts of questions. Now, you won't have done that in lesson, but I think it's worth mentioning in order for you to achieve those full marks on all of those questions. Now, I'm just going to move this. I'm going to turn it off because it's starting to form those small grains. I'll let it cool, and then I'll be moving it to this window to leave it for 24 hours in order to form some crystals like these.